guess we can see we're all wearing colorful medieval outfits, right? And in the morning session, they didn't actually explain what these different colors are. Maybe I'll spend a second to talk about it, right? So there's a color for the school. Many of you wearing Carolina blue, that's marvelous. And then also color for the field of study, like science, philosophy, that's gold and blue, and engineering, that's orange. So there's an orange color here, and so on. And it's a tradition, perhaps Western tradition, that for such a big occasion, so we're wearing these insignia and outfit that show our pride and our appreciation for the studies we've pursued and the accomplishment we have done. So on behalf of our department, to the class of 23, congratulations. You have done it. You are forever a physics Tar Heel. And you couldn't have done it without the support of those who are close to you, who have supported you over the years, to the families and relatives, especially the parents. Thank you. Thank you for the support you have done over the years. For the mothers in the room, Happy Mother's Day. Our graduates, you've begun your journey, this academic journey, many years ago. Almost right away, you were hit by the pandemic. So you were hit by the pandemic, and then you had to struggle and you fought through the challenges of the waves, right? So we didn't know any waves, although physicists know waves, but these are kind of different waves. You could analyze it with the mathematical know-how you've learned. The lockdowns and isolations, the on-ramp and off-ramp, sometimes embarrassing, sometimes really challenging. And on top of all that, the rigorous academic program you pursued. You have overcome, you preserved, you achieved, you succeeded. Congratulations. Maybe I should kind of spell it out. You have experienced the entirety of this once-in-a-century pandemic, right? It's unprecedented. You succeeded by graduating from one of the top public universities, or maybe the top public universities, with a coveted physics degree. Congratulations. We're really proud of you. So in terms of numbers, the room is totally full. We're not quite political science, although it's kind of key. Yeah, but we're graduating between 40 and 50. You know what? This is the largest class in the entire Southeast. Wow. Many years in a row. So we all know you've achieved an important milestone in your career. You're about to start a new one. You'll be facing new challenges, be it a first new real job, graduate school, and perhaps for the first time moving away from home for the Carolinians, right? And perhaps you're apprehensive, wondering whether things are going to be okay, whether they're going to work out. We are confident as a faculty that you are well prepared to face any future challenges you may face. Carolina physics graduates are tinkerers, thinkers, problem solvers, doers, and leaders, you are really ready to take on the world. Graduation is a time for us to say goodbye, and tomorrow we say good luck to you, and forever, go Heels. All right, it's my distinct pleasure to introduce our speaker, Dr. Greg Magretsky. Greg received his BS in physics from Carolina in 2004 with a minor in math, and then a MS and PhD in material science in 2010, also from Carolina. For his graduate studies, he studied and discovered new phases of nanomaterials. He studied their surface chemistry and catalytic properties using nuclear magnetic resonance techniques. He is a leading expert in countering weapons of mass destruction, CWMD. Very important arena that he is a leader in that. And he holds the DoD, Department of Defense, top secret clearance. He is currently the senior program manager of CWMD at the Patel Memorial Institute, a private nonprofit applied science and technology development. Prior to that, he was a CWMD program manager at the Department of Homeland Security. He published a dozen of refereed scientific publications and filed a patent. Without further ado, Dr. Magretsky.
All right, good afternoon, everyone, and thank you, Dr. Tsui, for that nice introduction. You mirrored all the topics of my speech, so I can go home now, right? Class of 2023, and all the parents and support groups, thank you so much for giving me the opportunity to speak in my home away from home, UNC Chapel Hill. Especially here in this physics department that I called home for many years, many nights, many days, etc. First thing I want to say is congratulations to the graduating class. You did it. You passed physics. You did it. I know how hard you must have worked. You have worked. Please take a moment or many moments to bask in your achievements. I know firsthand what you have achieved, except you probably had it harder now that Pluto is not a planet and Higgs boson has been discovered. Something did not happen. I was there. Just a theory. Nevertheless, a physics degree from Carolina will take you a very long way. And the paths you can take are numerous, and that is kind of what I want to focus part of my talk today. And I just want to reverberate on what Dr. Tsui said. You have the tools to succeed in anything you put your mind to. And of course, I have to wish Happy Mother's Day to all the mothers out there. Congratulations if your kids are here. It warms my heart and fills me with hope and gladness to see so many of you here today. When I graduated in 2004 with my BS, there were like 8 BS graduates, maybe a handful of BAs for a grand total, I think under 15 total graduates, maybe like 3 PhDs. This is a testament to this program, to this university, and to you especially. Well done, everyone. You guys have a lot of strength, so well done. Very quickly, I want to give a thanks to my family who's here with me. They are my bedrock, my parents, my wife, my kids. They're here. They're my support system. They're the reason I push myself every day, and much of the reason why I'm standing here before you. Whenever I come back to Chapel Hill, which happens rare and rare these days, I still feel welcomed and inspired. I'm going to sound corny, but it's an intellectual reset that I crave every time I walk from Franklin Street to Cameron Avenue. My love for this place runs deep. I've been told that I bleed Carolina blue. I should see a doctor about it. I also wonder if my dedicated Linda's booth is still there. My carvings in there. Now I live in Maryland, which is Big Ten country, but when I first moved there, it was still ACC country. Thanks, Maryland. And yet I still inject the fact that I'm a UNC grad in general conversation twice a day, on MS Teams and in person. It's been around 20 years since I last stepped foot in these classrooms as an undergrad and about 15 since grad school. But I must admit it feels like yesterday. Time in college only lasts 4 or 5 years, but memories last a lifetime. I know how cliche that sounds. You probably heard this a million times just this past weekend. But it's true, and I definitely feel it that way, especially when I look in the crowd and I see so many familiar faces here. It's uncanny. A little bit about myself. I graduated at UNC in 2004 with a BS in physics, and then again in 2010 with a PhD in material sciences. Now I'm a senior program manager at a company called Battelle, and Dr. Tsui gave a good brief discussion of what it was. It also manages national labs, just to throw it out there, 9 of them. I'm directly responsible, or in the middle of proposing, about $5 to $10 million a year of government-sponsored technology development programs in chem biodefense. I focus on bridging the gap between basic scientific research that's done at universities, at Army labs, and the user, the applications and technologies. My knowledge of physics and material science directly helps save lives of warfighters and provide first responders the tools they need to respond to counterweapons and mass destruction events. As my old principal investigator mentor at Edgewood's Chem Bio Center said, we're getting solutions from the beaker into the hands of the warfighter. What I consider to be my biggest accomplishment over the last 15 years is that I have the ability to walk in most Department of Defense and DHS Chem Bio labs and start off a collaboration or a funded program. And every day I leverage my physics degree to help develop these technologies to detect and eliminate weapons of mass destruction. But none of that would have been possible without the foundation I laid right here at Carolina. So, class of 2023, over the last 4 to 10 years, depending if you were undergrad or grad student or undergrad with lots of victory laps, you've gone to class, excelled, worked in a laboratory setting, gotten results, perhaps you published, manuscripts, papers, maybe even gotten a patent. Most importantly, now you're graduates of one of the best universities in the world, and I really do mean that. This degree that you have, it offers you so many paths to go forward. It's your ticket to the world. Now you can go in any direction you want. For me, my journey took me to be the top of my field, kind of a partner of the Department of Defense and Homeland Security for their Chem Bio Defense enterprise. And in order to get to where I am right now, if you please let me, I want to share the path that I took. So I grew up in Charlotte and got accepted in Carolina early admission, class of 2004. By summer after sophomore year, I started working in Dr. Tsui's and Dr. Wu's labs, studying the local thermal properties of metallic gases. And that's where I really started to fall in love with material sciences. So after graduating into December of 2004, I re-entered UNC to pursue my PhD in material science. And we focus on understanding the structures and surface chemistries of titanium dioxide nanomaterials and their applications. It's also where I fell in love with the application space, not beyond just the beaker, beyond just the science. So when I was graduating, I came to kind of a crossroads. And I wanted to know which direction should I go. Should I stay on the academic path, pursuing basic exploratory sciences, or am I going to go in a different direction, to accept a U.S. Army postdoc fellowship, to pursue more of an application-based research? They both offered comparable salaries. They would both require me to relocate out of the state, which I call home for a long time. But the two paths differed philosophically. I chose the latter path because to me, and this is different from everyone, I was very interested in that application space. I was more interested in, so I chose the industry path. But even in those early days of undergrad and graduate level research, I realized some very valuable lessons that I still heed to this very day. The first one is that without collaboration and working together, there is no path forward. Whether it's a homework study group back in college or high-level research, you do not know it all. and nor are you going to necessarily have all the tools to, or the resources to solve complex, large problems. The other lesson was find your mentors. People who want you to succeed and provide advice and encouragement when things, as they often do not go your way. I was fortunate and lucky to find such mentorship at Carolina with Dr. Wu and Dr. Tsui and also Dr. Washburn, who are unfortunately not here. I have also had great mentorship throughout my professional career and have never been too proud to ask for help and advice as needed. It takes strength to admit that you need help, and even more strength to ask for it. It's not a sign of weakness. It will only make a better result. Physics is a very versatile degree. I want to give you some pretty tangible examples from my own path on how I used the skills and the knowledge from Carolina, both in undergrad and grad school, in my professional life. But first, I want to focus on one major difference between academic path and then industries, and that is really the motivation for the research. When you choose an organization, you go to an organization, whether it's outside of academia, science, research, development are all tools to get to tangible solutions, or tangible problems. It's no longer really doing science to study the basic principles and to publish in the next Nature journal. It's really to solve real, tangible problems and challenges. When I was a postdoc in Edgewood's Chem Biocenter, I translated the research from my grad school towards focusing on solving how to destroy hydrolyzed EX, sarin, mustard gases. And I leveraged the NMR techniques that I learned at UNC to look at the reactive chemistries. I leveraged the surface chemistry tools that I learned right here, like FTIR, IR, or other techniques, Raman, to study the surface chemistry of these materials. When I became a principal investigator at Chem Biocenter, developing these new materials, I always mentored the new postdocs, new technicians, new scientists that came from the world of academia, that here you're problem solvers, and eventually you're going to be saving lives of warfighters. There's no other way around it. So solutions you're working in the lab is eventually going to end up in the field directly. After serving as a principal investigator for 3 years, I again faced the crossroads. Do I want to remain a bench scientist studying very focused problems, or am I looking for something else? I've always been interested and motivated by how the first principles of physics manifest themselves in big picture problems and concepts. How do these research efforts translate to real solutions? In the lab, you focus on a deep understanding of a very niche problem all the time. Well, not all the time, most of the time, I apologize. For example, how does a surface pKa translate to the surface reactivity of a certain material? And you'll learn how to manipulate that factor. But I'm always interested, how does that phenomenon in the bench scale translate over into the actual device or technology or real world use? So I had the opportunity to leave the world of bench science and enter the world of technical program management. To start that journey, I accepted a position as a systems engineer at an advanced development organization that takes these basic concepts and transitions them and engineers them into real solutions. In this case, it was for chemical biological defense. And the systems engineer path led me down the path of this program management. In this position, I'm no longer analyzing an MR spectra or XRD spectra or FTIR spectra on a daily basis. What I am doing is solving bigger problems on a bigger scale using those principles that we learned. So this brings me back to you. You are now problem solvers. You have the tools and the mindset to solve complex problems that may not have an obvious answer. Unlike other scientific principles, physics never asks you to memorize anything. You start everything from the ground up, from the basic principles up. This physics undergrad curriculum and grad curriculum trains and teaches you how to take complex problems, parse and whittle them down to their components, and build them back up in a systematic way to find your answer. There'll be times in your lives where you'll get overwhelmed with processes and people who just don't understand what you're trying to accomplish. It doesn't matter whether you're in an academic environment, technical, not technical. Physical sciences will be replaced by social sciences. Whenever you find yourself overwhelmed by bureaucracy, things and people just not making sense, always go back to the basics. Revert back to basic fundamentals and first principles, and everything else will draw from that. The best way to break down these log jams is stick to these fundamentals. You're lucky. Physics is the quintessential fundamental discipline. From where all other technical disciplines derive, your mindset is now rooted in foundational principles to be able to build things back up. It's not just memorization of formulas or understanding the potential roles and the placings. Also, be prepared to communicate complex concepts to people who do not understand the science. Oftentimes, I don't deal with trained physicists or chemists. I deal with warfighters, soldiers. I deal with first responders, emergency managements. These folks, they want solutions. And we live in a world where the solutions that we give them are often pretty complex and technical. It's a significant part of my job to communicate these complex concepts to those who don't necessarily understand them. There'll be many times where you have to look at a beaker and a solution that sits in there and see what it can become. Don't give up if someone doesn't get it, and don't be afraid to apply your understanding to get that solution. Originally, my friends and family wanted me to say that physics is not just EMC squared. But in this crowd, I know that's cliche and silly, so for you, I will leave it that physics is not just that L equals T minus V. You must think about how T minus V impacts the world. Remember, your imagination and vision of how to apply these basic principles is more important than memorization and knowledge and understanding. Thank you.
Thank you. Let's give another round of applause.
You look a little longer than you really were.
Okay, now we're, the next is the undergraduate awards presentation. It's given by Dr. Bronca and Dr. Weinberg's work.
Hello everyone, and congratulations again for making through the 4 years in physics in this department, and I know it's very challenging. And it's my pleasure to hang out this award with Jennifer Wegenbuth. All of you know her. She has been extremely supportive to all of you, I know that. Whenever there is a problem, Jen is the person to which everybody goes to. So it's, and actually is supporting me right now in this role as well. Thank you, Jen. So we start with the undergraduate awards. And the first one goes to Aaron Matthew Miller, the Paul Sharing Outstanding Senior Award in Physics. Congratulations. Our next award is the Daniel Johnson Outstanding Junior Award in Physics, and goes to Hayu Ma. The next award is an award that we started 2 years ago, and this is to recognize the achievement of some of our